With what speed must an object be thrown to reach a height of 91.5 meters? Assume negligible air resistance. So we have our first two basic equations here for velocity and acceleration. We break those down even further, and then we also have the derivation of these two equations right here. But what we do have is we have acceleration at negative 9.8. Remember, negative only means direction in this case, not an actual negative. We have the x2, which is 91.5. x1 is going to be 0. That's our starting point. We don't know v2. We know that v1 is 0. Once again, starting from rest. And we don't know time. I don't know what it is with kinematics. We're always looking for time. But that's okay. We've got enough to start. So if we look at this equation right here, as per usual, we see that x1 being 0, v1 being 0, basically marks out the entire first half of this equation. Not even going to use it. So it's going to be x2 1 half acceleration times time squared. And remember, we're looking for the actual acceleration, the speed that it has to be thrown, the v2. That's what we're looking for. But we don't have a change of time. We can go ahead and manipulate this equation though to get to that point. Looking for delta t, we come here, square root x2 1 half of the acceleration, put in all our numbers, 91.5 being the x2, 1 half of the negative 9.8. Remember, negative is only the indication of direction, not an actual negative in this case. And then once we get that, we get a time of 4.3 seconds. Well, okay, what good does that do us? We'll come over here to our acceleration equation. We find out how to get v2. We manipulate this equation. We find that the acceleration times the change in time plus v1 is going to equal v2. v1 being 0 means that 9.8 times 4.3 gives us the velocity we have to throw it in order to get it to 91.5 meters, and that is 42.1 meters a second.